Now let's find how to change speed and maintain course in the Navy version of this. And I apologize, it means we're going to have even more stuff going on at the center of the plot here. However, again, if you do it yourself, you can kind of visualize it better. Also, it means that we only need to do this calculation or set up ER once, because just like for the course change, we know that we want this to be our new DRM for contact C, meaning we want this to be our new direction of the RM vector for contact C. However, instead of coming out to here, because this is the same distance away from the center as our original vector, meaning it's the same speed, we would now stay along this original ER line because we're maintaining course, but we're going to come down to the point where it intersects the RM vector that we want. So we're going to come down to this point right here, and now that is R double prime. Now from there, we know that it's going to create an RM vector like this for contact C, and it's going to give us the DRM that we want. Like I said in the last video, it's going to now, of course, change the speed of relative motion. So it's going to move slower along this DRM than it would have otherwise. However, it's going to give us the same CPA we want. It will affect the other contacts. So if this is the M for contact B, meaning that this ERM triangle was the original vector triangle for contact B, now the R double prime to M is going to look like that. It's really short because the SRM is really low. It's not moving very fast. But you can see, if we come out to M3, interesting. Oh, crap. We get a DRM for contact B that looks like this. And why is that different? For whatever reason, well, I'll tell you why. This DRM for contact B looks different than the DRM we calculated the first time for the speed change, which is all the way out here. It's clearly further away than our DRM in this one. And the reason that is because of how small of a scale we're working with in this problem compared to the larger one here. If we're using the 5:1, all of our triangles are nice and big out here, and you can see our contact B triangle is that big. Here the contact B triangle is this big, it's a lot smaller. And our new course change or speed change triangle is tiny compared to the one here. So it's kind of difficult, especially considering how crowded it was, to get an accurate measurement of where the M here would be for the R double prime to M vector in the speed change. And that meant that the direction was going to fluctuate a lot. And that small fluctuation was the difference between coming in a lot to here and passing really close, or coming out to here where it's nice and clean. Which is why we get a much less fortuitous DRM for contact B based on our speed change here. Let's see what it does to contact A. If this E to double prime is our new vector, and our A vector, or A vector triangle, was ERM here, well then an E to R double prime to M triangle would look like this. And if we were to extend that over to M3 of contact A, we get basically the same near collision course that we did in the other problem. So while comparing the two showed a little bit of an error in contact B, I don't know, I suspect that this is more accurate than the other plot because the other plot involved a smaller triangle. We got essentially the same information for contact A, which is that a change in course will reduce the CPA for them. Remember, that's The fact that the speed change here is not as safe as the course change would have been does not mean that the speed change is always the wrong option. You could choose one or the other and you could see which one works. The rules say you should stick to the course change. And in this situation, the speed change is not going to work, or a different speed change would be necessary. And to review, for the Navy system, if you were to reduce your speed, you would just have to measure out a new speed along the ER line you originally drew, and then you can automatically set the RMs for all of the contacts off of them. Makes it a lot faster. It's of course very, very crowded now in the center, but I do think it is now faster to plot them out in all directions.